Welcome once again to the engineering chemistry course. We are starting with the organic fuels. Before starting the today's lecture, just have the recap of the previous class. In the last class, we have discussed about the ultimate analysis of the coal, in which we learned about the determination of percentage of carbon, hydrogen, nitrogen, oxygen and sulfur in the coal sample and the significance of the ultimate analysis. Now in today's class we are going to start with the secondary solid fuel coke. In this we will learn about the carbonization process, types of carbonization process, low temperature carbonization and the high temperature carbonization. After that we will discuss about the manufacturing of metallurgical coke by Beehive coke oven method. So let us begin with the topic coke. We know coke is the secondary solid fuel. When coal is subjected to destructive distillation, it leaves behind a white, lustrous, dense, strong, porous and coherent mass known as the coke. So coke is a secondary solid fuel which is formed by the coal, and the process through which coke is formed is called the carbonization process. Basically, carbonization is the process of heating the coal in absence of air or oxygen to a sufficiently high temperature so that the coal undergoes decomposition and yields the coke, which is richer in the carbon content than the original coal. So, what is the basic reaction of the carbonization? See here, when coal is heated in absence of air, it gives the coke. This is the carbonization reaction, and besides the coke, there will be the formation of the coal gas also as a side product, byproduct of this reaction. So the mandatory condition for this is the absence of air. This is in absence of air or oxygen. So basically carbonization process is the heating of coal in absence of air or oxygen to a sufficiently high temperature so that the coal undergoes decomposition and formation of coke takes place. This is the carbonization process. On the basis of the heating temperature or the carbonization temperature, the carbonization process is of two types: low temperature carbonization and the high temperature carbonization. If the carbonization process is carried out at 500 to 700 degrees centigrade, then the process is called low temperature carbonization. While if the heating of the coal is carried out at 1000 to 2000 degrees centigrade, then the process is called high temperature carbonization. On the basis of this temperature range, there will be vast difference between in the properties of the coke formed by the LTC or by the HTC. For example, the calorific value of the gas, which is produced as a byproduct, coal gas. So the calorific value of the gas produced by LTC is higher, that is 6500 to 9500 kilocalorie per meter cube, while the calorific value of the gas produced by the high temperature carbonization is lower, that is 5500 to 6000 kilocalorie per meter cube. The hardness of the coke produced by this low temperature carbonization, it produces the soft coke, while the high temperature carbonization produces the hard coke. The volatile matter content in the coke produced by LTC is 5 to 15%, while the volatile matter content in the coke produced by HTC is only 1 to 3%. That means it produces the better grade of coke. The mechanical strength of the coke produced by LTC is not very high, while HTC produced coke is very strong. In the LTC, yield of the coke is only 70 to 80%, while in HTC, yield of coke is 65 to 75% only. Similarly, the smoke produced on burning is LTC produced coke burns with the smokeless flame, while HTC produced coke burns with the smoky flame. Uses: the LTC produced coke is the soft coke, that's why it is used only for the domestic purposes, while the HTC produced coke is the hard coke, that's why it is useful for the metallurgical purposes. So the HTC produced coke is the metallurgical coke. So let us begin with the manufacturing of the metallurgical coke. The metallurgical coke can be produced by Beehive coke oven method or Otto Hoffmann's method. These are the two different type of ovens in which heating of coal can be carried out. That's why the method is based on the name of the oven. First is the Beehive coke oven method, second is the Otto Hoffmann's oven method. So these are the method for the manufacturing of the metallurgical coke, and we know the metallurgical coke is produced by the high temperature carbonization. So let us begin with the Beehive coke oven method. This is the construction diagram of the Beehive coke oven. This is the dome shaped oven. It is the earliest and the cheapest process for the carbonization of the coal. The Beehive oven is a fire brick chamber having a dome shaped structure. It is called Beehive oven because it resembles in shape to that of the beehive. It is about 4 meters wide. This is 4 meters wide and 2.5 meter high. This 2.5 meter high, having two openings, one at the top of the oven which is used for the coal charging, and second one is the side opening which is used initially for the air supply and after the process for the coke discharging. The coal is introduced through the top opening in the dome and spreaded evenly on the floor of the oven to produce a layer of 0.6 to 0.9 meter deep. Initially, some air is supplied to ignite some part of the coal, and some of the coal get started combustion, and due to this combustion high amount of heat energy released, which is further used for the carbonization process. At the end of the carbonization, the hot coke is quenched with water in the wet quenching, or it may be quenched with the dry nitrogen inert gas, which is called the dry quenching method. The yield of the coke is about 70 to 80% in this method. The byproducts are non-recoverable in this method. There is no means to recover the coal gas in this method. So this is a very simple method. Again, I am repeating, it is the fire brick chamber having a dome shaped structure. That's why it is called the Beehive oven. It is about 4 meter wide and 2.5 meters high, having two openings, one at the top of the charging, one at the top of the oven which is used for the charging the coal from the top, and another on the side opening which is used for the initially for the air inlet and after the process for the coke discharge. The coal is introduced through the top opening in the dome and spread evenly on the floor to produce a layer of about 0.60 to 0.90 meters deep. Carbonization starts and volatile matter burns inside the partially closed side door. Carbonization is completed within 2 to 3 days. At the end of the carbonization, the hot coke is quenched with water or dry nitrogen, and it is discharged manually through the side door. The yield in this process is 70 to 80%. But the major disadvantages of this method are: first, due to the partial combustion, yield of coke is very low. No recovery of byproducts in this method is possible. The byproducts are very useful because the main byproduct is the coal gas, which can be used as a fuel gas. That's why it is not beneficiary that we cannot recover the byproduct of this method. Third is the lack of flexibility of the operation. So these are the major disadvantages of the Beehive coke oven method. Among these three disadvantages, non-recovery of the byproduct is the major disadvantage of the Beehive coke oven method. Now it's time to check your learning. Read the question on your screen carefully. Pause the video for a minute and think about the correct answer of this question. Metallurgical coke is manufactured by A. Low temperature carbonization, B. High temperature carbonization, C. Combustion of coal, D. Degradation of coal. Yes, you are right. The correct answer is the high temperature carbonization. Why it is the correct answer? Because we know that the high temperature carbonization produces the hard coke, and for the metallurgical purposes hard coke is used. That's why metallurgical coke is produced by the high temperature carbonization. So let us revise what we have discussed in today's class. Today we discussed about the secondary solid fuel coke. Coke is produced by the primary solid fuel coal. Then we have learned about the carbonization process. Carbonization is the process of heating the coal in absence of air. Mandatory condition is the absence of air or oxygen. When coal is heated in absence of air, there is the formation of the white, lustrous, dense, porous mass, coherent mass, that is called the coke, that we have learned today. On the basis of this heating temperature, the carbonization process is of two types: low temperature carbonization and the high temperature carbonization. If the carbonization process is carried out at 500 to 700 degrees centigrade, then the process is called low temperature carbonization. While if the process of heating the coal in absence of air is carried out at 1000 to 1000 degrees centigrade, then it is called high temperature carbonization. After that, we have started with the manufacturing of metallurgical coke by Beehive coke oven method. But obvious, if we are talking about the metallurgical coke, that means we are talking the high temperature carbonization. For this purpose, two types of oven may be used. One is the Beehive coke oven method, which is the earliest method to produce the coke, and second one is the Otto Hoffmann's method. The main disadvantage of the Beehive oven method is the non-recovery of the byproduct. To overcome this disadvantage, second method is adopted, which is the Otto Hoffmann's byproduct recovery method, which we will be discussing in the next class. Thank you. Take good care of yourself and keep enjoy e-learning at home. Keep smiling. Thank you.